Okay, so for the first one, sine of angle A. So here's angle A. Now from angle A, let's label the other sides. The hypotenuse is really easy to pick out. Which one's the hypotenuse? 17. That's always the longest side. The side that's opposite the right angle. Which is the adjacent side? The 15 is adjacent because it's touching angle A. Now, the hypotenuse stays the hypotenuse no matter what angle we're looking at. The adjacent and the opposite are going to change. Obviously, this one's the opposite. Will change depending on which angle. If we're looking at angle A, this is the adjacent and this is the opposite. If we were looking at angle B, they would switch spots. So the sine of A, what is the sine? It is opposite over hypotenuse. So here that would be 8 over 17. Cosine of A, so it's still the same angle, so we're still dealing with the same sides. Cosine is adjacent over hypotenuse. So what sides are we looking at? 15 over 17. Good. Tangent of A. Tangent is opposite over adjacent. So what sides are we looking at? 8 over 15. Good. Cotangent is adjacent over opposite. So we're looking at adjacent side's 15, opposite is 8. So 15 over 8. Of course, you could reduce that, but I'm not going to worry about it right now. Secant of A. Secant is hypotenuse over adjacent, which is going to be which sides? (17 over 15 would be the adjacent. Cosecant is hypotenuse over opposite, which will be the hypotenuse is 17. The opposite is 8. Any questions on those? Down here, we are told if B plus D equals 90 degrees. What does that mean? That means B and D are complements. And I worded this wrong over here. That's just that if sine of D is 0.387, what is the cosine of B? B and D are complements. So the sine of D has to be equal to the cosine of B. So the cosine of B is equal to the sine of its complement. Does that make sense? What's that? So like if I have, that cofunction, the CO literally means of the complement. So let's say I still got B and D add up to 90 degrees, so they're still complements. If I tell you that the tangent of B is 2.83, what's the cotangent of D have to equal? 2.83, they have to be the same. If they're cofunctions, the function of one has to equal the cofunction of the other. So since B and D are complements, the tangent of B and the cotangent of D will be the same thing. If I tell you that the secant of B equals 1.83, the cosecant of D must equal 1.83. Yes.
How do we make that a problem if we don't remember that? Or just to prove that that's true.
What you could always do if you were really stumped here. Okay, sine of d is 0.387. So you could do second sine 0.387. And get, okay, d is 22.77, right? Well, then I'm going to subtract that from 90 to get its complement. And then I'm going to do the cosine. That answer is 0.387. So you can go about that way too, of finding the angle and stuff like that. So if I tell you that sine of A is 0.859, how do I find angle A? Yeah, second sine 0.859. So 59.20 degrees. Now remember, there are some other notations we saw. That is sine inverse. That's saying do the, oops, I wrote that out wrong. Let me try that again. That sine inverse of 219 is saying do the inverse sine, or sine of A equals 0.219, find A, whatever. So we're going to still do second sine 0.219, 12.65 degrees. And a third notation that could be used there, remember we mentioned the arc sine. Arc sine of 0.555 is the exact same thing. It's saying do the inverse sine, second sine 0.555. So 33.71 degrees. If I were to give you arctangent of 2.5 equals, I'm asking it for there in degrees and minutes, so the nearest minute. So arctan just means inverse tan, so second tangent, 2.5, 68.20 degrees. But all I'm going to do is put down the 68 degrees here. And now I could do the conversion to DMS. Now I'm just going to convert it by hand. I'll subtract the 68 degrees and multiply what's left by 60 to turn it into minutes. So that's 11.9 or 12 minutes. So 60 degrees.
Put it into seconds too.
If I wanted to put it into seconds too, I'd subtract the 11. So it would have been just 11 if I was putting it into seconds too. I'd subtract the 11 and then multiply by 60 again. So 55 seconds. 11 minutes, 55 seconds. Or I could have just done second tangent 2.5 and gone into the angle menu and select the DMS. 68 degrees, 11 minutes, 54.9 seconds. That's one of the quirks on this calculator. Is it goes out. This calculator is the only place I've ever seen anything express seconds past one decimal place. Usually one decimal place on anything for the seconds is standard. Any questions?
Up your game up the black stallion status. What's happening there? Sure.
On this quiz, I'm down on bottom on the matching. Option A has a misprint. That should say cosine 90 degrees, 20 minutes, or 29 minutes. So again, option A down on bottom, that should say cosine 90 degrees, 29 minutes.
Wait, say that again.
Down on bottom, option A. It says cosine 9 degrees, 29 minutes. Should be cosine 90 degrees, 29 minutes.
Now, do we have to reduce the fraction?
No, you can leave them just as they are. Thanks, sir.
He does free touch-ups though, huh?
Yeah. But most reputable artists do. I would check out Crimson Heart.
So that good, huh? Everybody in there? You're
Yeah.
in there.
Well, I know they got at least 3 guys in there.
Heard nothing but good things, but they've been there.
They originally owned Bombshell before they sold out to him.
Alright.
Yeah.
Were they taxing them out of here? Really?
Mm-hmm. But he only worked for them for about 2 months before
Yeah.
He bought them out. His wife from Crimson Heart got arthritis in her hands, so she had to slow down. So they couldn't run both stores again. Because she used to do most of the Rice Lake store.
Bombshells? No.
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 Crimson Heart owned Bombshell.
Yeah.
It was Crimson Heart up until just a couple years ago.
Would you want us to change that A2 again?
Cosine of 90 degrees, 29 minutes. And actually, technically, it should be 89 degrees, 29 minutes. Sorry. Then it should match up. Thank you. Thank you.
He's not finding the complement, just the bunch the calculator there.
You can, yes. That'll should come up with the right answer. Okay, I realize some of you are still working on the quiz, and that's fine. Please feel free to set it aside and take as much time as you need. New stuff. So what we've been doing so far is just learning the trig functions and how they work. What we're going to start today is actually now applying them to triangles. So let's say that I have a triangle like this. And for now, we're going to stick to right triangles for a few days at least. So in this right triangle, I am told that this angle here is 38 degrees. And I am told that this side over here is 12 millimeters. I can find the rest of my sides. Now I'm going to label this A, B, and C. So this here is side little a, little b, little c. If I want to find side B, looking at this, I first need to know, what do I already know? Well, I already know angle A and side A. So from that, I know this angle here. I know this side, and I'm looking for this side. So from that angle, that obviously 38 is the angle I'm going to use. From that angle, let's label all the sides. C up here is the easy one. That would be the hypotenuse, across from the right angle. B would be the adjacent. And A over here is the opposite. So now as I'm breaking this down, I look at what side do I know and what side am I looking for. I know the opposite side, and I'm looking for side B, which is the adjacent side. Which trig functions deal with opposite and adjacent? There's two of them, tangent and cotangent. Now cotangent isn't on our calculator, so we're not going to mess with it. But the tangent of an angle is opposite over adjacent. So we're going to fill in what we know. We know that angle is 38 degrees. So tangent of 38 degrees. We know the opposite side is 12 millimeters. The adjacent side is side B. That is what we're looking for. To solve this, it's simplest when I have a trig function like this, if I make it into a proportion. So I make it into a proportion by making that tangent of 38 over 1. Now to find B, what I'm going to do is just like in the other proportion, I'm going to cross multiply and divide. So it'll be 1 times 12, which is 12, divided by the tangent of 38 degrees. So 1 times 12 divided by the tangent of 38. So I get that B is 15.359 or 15.36, we're going to call it. Millimeters. When I'm looking for a side, we will almost always, well, we will always make a proportion. And then cross multiply and divide. So looking for side C now. Now that we have two sides, we do have some options. I could do a squared plus b squared equals c squared. The only thing I don't like about that is this is a calculated value, the 15.36. And there's two issues with calculated values. One is it's going to be rounded. Because remember, on the calculator, it's not really 15.36. It's 15.359299959, blah, blah, blah. So it's going to be rounded. And if I use a rounded number to calculate another number, it compounds or magnifies that round off error. The second thing is I calculated this number here. So there's a chance that I screwed up and that number's wrong. So yes, I could use that to find c by doing a squared plus b squared equals c squared. Or I could use it by doing cosine. But I prefer to go back to numbers that were given to me because I know those are right. At least if they're not right, it's not my fault. It's somebody else's fault, right? So I know the 12 millimeters. Based on the 12 millimeters, that's the opposite side. I'm still using this angle, 38 degrees. That's my opposite side. If I'm looking for side C here, that's the hypotenuse. Opposite and hypotenuse would make up the secant or the sine, or cosecant or the sine. So the cosecant is not on our calculator, so we're going to use the sine. Sine of an angle is opposite over hypotenuse. So again, I'm going to fill in what we know. We know the angle is 38 degrees. Opposite side is 12 millimeters. Our hypotenuse is side C, which is what we are looking for. So once again, I put the sine of 38 degrees over 1 so that it becomes a proportion, and I'll cross multiply and divide. 1 times 12 is 12, divided by the sine of 38 this time. Which is 19.49. So I can come up here, this has to be 19.49 millimeters. Now if I really wanted to, I could double check this. I could put the 15.36 and the 12 in and I could square them and see if it comes out. So let's do that. What'd you say? It does? Okay. And yeah, it does give me 19.49. You can see there's a little bit of round off error because it's 4917 instead of 4912. But what do you think? Yeah, we'll go through more examples. So here, let's skip that one. We'll change this up. Actually, we'll give you this is 8 millimeters here. And this angle here, I'm going to give you is 31 degrees. I'm going to call this angle A, B, and C. So this is side little a, little b, little c. First thing I'm going to ask you to find is angle B. This requires no trig at all. What's B have to be? Why does it got to be 59? Yeah, all three angles have to add up to 180. So you've got 90 here and 31. Subtract from 180, you got 59 left. So let's find side C here. So now we're going to go back, like you said before, we're going to go back to the stuff we're given because we know that's right. We know we didn't make any mistakes because somebody else gave that to us. So I'm going to use the 31 degrees here. Now I'm going to label my angles according, or my sides according to that angle. So that side, the 31 degrees, side C is which side? Hypotenuse. Of course, that doesn't matter which angle I'm looking at. Side A is the opposite. And side B down here, adjacent. So if I am looking for side C, again, I look at what I'm given. From angle A, I'm given the 8 millimeters, which is the adjacent side. So I'm given the adjacent side. I am looking for, I'm finding the hypotenuse. So the sides I am dealing with are the hypotenuse and the adjacent side. Well, hypotenuse and adjacent would make the secant, or the cosine would be the other one. Cosine of an angle is the adjacent over the hypotenuse.
So now we finding C the angle, or
We're finding C. Little c would be a side.
this is
We already know all the angles. So we fill in what we know. The angle is the 31 degrees. The adjacent side is the 8 millimeters. And the hypotenuse is what we're looking for, that side C. We put this over 1. And now we're going to cross multiply and divide to find C. 1 times 8 is 8, divided by the cosine of 31. Is 9.333. So C here is 9.33 millimeters. Again, that was because we were looking for a side. We made it into a proportion and we cross multiply and divide. Let's say now we're looking to find side A.
How do you know that you put the adjacent of the hypotenuse first?
Because that's the definition of cosine.
But why do you know that you're...
Because we're given the adjacent side and we're looking for the hypotenuse.
Yeah.
So then we go look in our list,
Yeah.
and we find that there are two functions that deal with hypotenuse and adjacent. The secant is hypotenuse over adjacent, and the cosine is adjacent over hypotenuse. The only reason I didn't use the secant is because cosine's on my calculator and secant is not.
Yeah.
Either one of them would work, it's just secant's tougher to do. So to find A, we're still given the adjacent. This time we are looking for A, which is the opposite. So we have the opposite and the adjacent, which would be cotangent or tangent. The tangent of the angle is opposite over adjacent. Again, the only reason we're using tangent instead of cotangent is because tangent's on our calculator and cotangent is not. So now we fill in. We replace the angle, theta, with 31 degrees. The opposite side is A, that's what we're looking for. The adjacent side is the 8 millimeters. So again, we're looking for a side, so we make it a proportion, and we'll cross multiply. So tangent of 31 times 8 divided by 1. So tangent of 31, make sure you close the parentheses on these because it will screw you up if you don't. Times 8 divided by 1 is still going to be 4.807 or 4.81. So this opposite side here is 4.81 millimeters. C up here, you had to cross multiply 1 times 8, then divide by the cosine of 31.
So we put cosine in 31.
Yeah, 1 times 8 divided by cosine 31. So, you have to ask me afterwards. I gotta get through this example. Okay, so if I'm asked to find here angle A, I look at what I know. Well, from angle A, I got to define these other sides. The 10 would be the hypotenuse. The side I'm looking for here, or the side I'm missing, I should say, is the adjacent. I'm not necessarily looking for it yet. And the 6 is the opposite. So what I know here, I know the opposite side and I know the hypotenuse. What trig functions deal with opposite and hypotenuse? Sine and cosecant. Yeah. But cosecant, of course, is not on our calculator. So we're going to deal with the sine. So from our definition of sine, sine of theta is opposite of hypotenuse. That's hard to keep straight, too. I want to do the same thing, secant and sine. So put in what we know. Well, we do not know the angle. Angle A is what we're looking for here. The opposite side is the 6 centimeters. The hypotenuse is the 10 centimeters. Now, since these are the same units, I can just cancel them out. I put the units in there only because I have to make sure that they're the same units on both sides. And now this is different from what I've done before. If I am looking for an angle, both examples I did up above, I was looking for a missing side. Here I am looking for a missing angle. When I'm looking for a missing angle, I am going to do an inverse trig function. So if the sine of A equals 6 over 10, the inverse trig function is telling me that A equals the inverse sine of 6 divided by 10. So on my calculator, I'm going to do second sine 6 divided by 10. 36.87 degrees. So this is 36.87 degrees. Now to find angle B, I could just subtract from 180 if I had to, if I wanted to. Or I could do B and then relabel my sides. If I'm looking at angle B, of course, this would become the adjacent side, and this would become the opposite side now. So there's a lot of different ways I can approach that. 6 over 10, yep, and then close your parentheses. I'm going to be giving you a new packet here. Page 355 through 354 in this new packet. Work on the odds. Finding missing angles and missing sides.
So then you find side B, you just use that.
A squared plus B squared equals C squared would do it.
But if you wanted to do it with trig, you do sine 36.87.
Yeah, well, you could do. It'd have to be either cosine of the 36.87 because that's the adjacent side there.
Oh yeah.
Or you could do tangent would work well, and then you'd use the 6 instead of the 10.
But you use the angle A that you found?
You would have to, yes.
Why is it that you always have to, okay, because that's the theta. Yeah.
So you guys want to take one for Carter?
You can. You won't get it till tomorrow if I have it.
Okay, we'll wait till tomorrow.
It's not stable.